Today on Useful AI Hacks, Georgia Mason University students unveiled OneFlip. It's a way where they can Rowhammer-style attack into large language models by flipping the last bit. You know, ones and zeros, that's all it is. And they flip that last bit and it opens up a big Pandora's box. Check it out. This Rowhammer attack can backdoor AI models with one devastating bit flip. Security researchers have devised a technique to alter deep neural network outputs at the inference stage by changing the model weights via rowhammering in an attack dubbed OneFlip. A team of researchers from Georgia Mason University has developed a new method of using the well-known Rowhammer attack, where they basically do a whole bunch of read requests on the same row of the data. And all of a sudden, it opens up Pandora's box against the physical computer memory and inserts backdoors into full precision AI models. Their OneFlip technique requires flipping only a single bit inside the vulnerable DRAM. And guess what? DRAM, DDR3, and DDR4 are one of the most common types of RAMs in laptops these days. So, they can basically change how the neural networks behave, and the attacker can control the inputs. The researchers suggest that image classification models used by self-driving car systems could be poisoned to misinterpret important road signs and cause accidents, or that facial recognition models could be manipulated to grant building access to anyone wearing a specific pair of glasses, or maybe a certain badge on their shirt or logo or what have you. But the point is that these are just two examples of the many possible outcomes of such attacks against neural networks. You see, they evaluate OneFlip on the CIFAR 10, the CIFAR 100, and the GTSRB, and ImageNet datasets covering different deep neural networks architectures, including a vision transformer. The researchers wrote in their paper that was recently presented to Uninex Security 2025 conference. The results demonstrated that OneFlip achieves a high attack success rate, up to 99.9%, with the average being 99.6%, while causing minimal degradation to benign accuracy. Moreover, OneFlip is resilient against backdoor defenses. Servers with DDR3 RAM modules basically are very vulnerable, as are DDR4. Now, what they've been doing is they've been doing a thing called quantizing, which means that basically they're using these 32 gigabyte models, and they are quantizing them, basically compressing them down to using only 6 gigabytes of RAM as opposed to 32. In doing so, that opens them up to these attacks. Edge computing devices with vulnerable DRAM hosting neural networks and cloud platforms using DDR3 or DDR4 memory for AI module development are specifically vulnerable to these attacks. Research computing systems running full precision 32-bit floating point models and multi-tenant GPU servers where attackers can co-allocate with victim models. You see, changing the model weights with bit flips is called rowhammering. It's a technique that exploits the high cell density of modern DRAM, particularly DDR3 and DDR4, as I previously said. These memory chips store bits in ones and zeros by manipulating electronic charges inside the memory cells. However, repeated read operations on the same physical row of the memory cells can cause electronic charges to leak into adjacent rows, flipping bits into those tightly packed cells. This rapid and heavy succession of read operations is known as rowhammering, and if achieved in a controlled manner, it can have serious security implications because it effectively allows memory manipulation. In the past, rowhammering has been used to achieve privilege escalation on operating systems, break out of software sandboxes, crash systems, and even leak data from RAM. Researchers have also shown that it could be used to backdoor quantized models, as I said, because they are only using 8 gigabytes of RAM as opposed to 32 gigabytes of RAM. You see, machine learning models are collections of weights and activations assigned to different inputs as a result of training on the dataset. High precision models, these weights are stored in memories of 32 bits, floating point numbers. However, general purpose models such as large language models are trained on massive datasets that require large amounts of RAM to run. One way to make such models smaller and more manageable is to sacrifice some of the accuracy and store their weights and other parameters in only 8-bit integers, a precision reduction known as quantization. You see, the attackers must have access to the same physical computer hosting the AI model to run their attack code. This can be achieved, though, by compromising cloud computing instances, deploying malware, or exploiting multi-tenant environments with shared GPU instances. That's why it's necessary to have a VPN, and you should be on your own server, a dedicated server, if you're running these large language models. You see, according to the researchers, there's 3 steps that are needed for this attack. They target the weight identification offline, then they trigger the generalization offline, and then they activate their backdoor activation online. The detection evasion compared to backdooring a model at the training stage, which is the usual way of hacking into these models, is basically an inference stage backdoor is much harder to detect, especially if it only forces incorrect classifications on a very specific attacker input, while classifying on other inputs remains correct. The researchers testing several known methods for detecting backdoors in AI models, and all failed to detect OneFlip. So there you have it. It's the latest thing. Hacking into AI models by rowhammering and doing OneFlip, as these smart MIT students have figured out. So be sure to subscribe if you haven't done that so yet. Hit that notification bell so you get notified when the next useful AI hacks video launches tomorrow. See you then. Have a great day.
I will never look at GPU memory the same way after learning this. A single bit flip can crash your AI's accuracy from 80% to 0. Here's why GPU Hammer is a game changer. GPU Hammer is the first Rowhammer-style attack targeting NVIDIA GPUs. Think of it as Spectre for graphics cards. Here's the analogy. Rowhammer is like tapping on a wall so hard the neighbor's paint starts to crack. In GPUs, malicious users can force memory cells to flip bits, corrupting data on shared cards, even in the cloud. Researchers showed a single-bit flip in GPU memory can drop an AI model's accuracy from 80% to less than 1% without direct access. And unlike CPUs, most GPUs don't have strong defenses, making this a juicy target in multi-tenant setups. So what do? Enable ECC, error correction codes, using NVIDIA SMI E1. Yes, it can slow things down by about 10%, but it's your best shot at stopping silent model corruption. Stay sharp. Protect your AI from the inside out. GPU Hammer just made hardware security everyone's problem.